वेरी गुड। सो देखो, आप लोगों ने इनिशिएटिव लिया है टू ज्वाइन द क्लास, यू आर, आई थिंक all of you are at your home right now, but this kind of initiative, like, I'm going to teach you alternating current, the fresh topic. Okay. Okay, Yogeshwari, is it clear? Clear. Okay. So, good afternoon, everyone. I welcome you all on this session of alternating current, and this is the very first session of this chapter. Previously, we have did with the electromagnetic induction, and now we will start with a very fresh topic, which is alternating current. This is a very short chapter, like it's like a capsule. Okay, it's like the energy capsule. These are the very very small capsules, but they contains a very large amount of energy and gives you enthusiasm and just keep you moving. Okay, and this chapter is like that only. This is a very, it's not very lengthy chapter, it's very small chapter, but the concept in this chapter and the if I go according to the exam point of view, this chapter worth a lot. Okay, so this is like an energy capsule. Okay, so do not forget these energy capsules type of chapter. Okay, so we will start with the very first thing here, which is alternating current. Got it? Clear? Sure. And try to make the notes of it. I'll be doing some question solving also in this session. So it would be better for you to understand the concept. Okay. चलिए. So first of all, what is the learning objective of today's class is the definition of alternating current. Like, what is, we know about current from the current electricity, that current is nothing but the rate of flow of charge per unit time. But what actually this alternating current is, I can guess ki by the name you are having a guess about it. Like alternating means something is oscillating. Okay. But what it is actually, we are going to see that first of all, definition of alternating current. Then, if it is a alternating current, it will be different from the regular current that we have studied in the current electricity. Then we have to know what is the mean value of it and what is RMS value. I think in 11th class you are aware about this term RMS in kinetic theory of gases. When we study that, we used to calculate RMS speed of the molecules of the atoms, VRMS, which is I think square root of 2 RT by M. I hope so. Is it the correct one? And the average velocity there will be root 8 RT by M. है ना? So here the hack here is the RMS term is not specific to kinetic theory of gases. RMS is a term that you can utilize for any physical quantity. Okay. And that would be if it is having very random values or it is varying. Okay. Now, then we will see what is phasor and what is phasor diagram, the concept of it. And you don't need to worry about it. Like, this is a very new term to you. What is phasor actually? And if you have studied this chapter in your regular classes, then this is not a new term to you, but there might be some concept that is being hiding from you in the class, but we will exploring them here. Okay, with the full enthusiasm and peace. So let's just get started with it. First of all, we will know what is the types of current that we have. So generally, we will talk about two types of current. First is direct current, which is DC, and the second one is this chapter that we are going to learn, alternating current. Okay. Till now, whatever the current we have deal with in the current electricity chapter or in any question before this chapter, we have calculated that whatever is the value of current that we define is automatically lies in the category of direct current. Okay. But in this chapter, we will see that what is actually the alternating current and how it is different from the direct current that we have studied. Okay. But basically, you remember that types of current we have is direct current and alternating current. Direct current is that current does not change the direction with time. जिसकी direction with the time it will not change its direction. That particular current is direct current. If you will see the balls, these balls, little balls are producing moving in this particular circuit. This small balls are nothing but the electrons, and it is being pushed by this battery. Okay. So we can say that this movement is like this in clockwise sense, and it is not changing with time. So this particular type of current is nothing but the direct current. But if the direction is being changing, you can see here in this, at firstly it is going clockwise and then it is moving anti-clockwise. So this type of variation, when current changes its direction with a regular interval, okay, then that particular current is alternating current. You can see in the animation also this type of current, like firstly it is moving clockwise and then it is moving anti-clockwise with a certain period of time. So this is the alternating current. Okay. हम कैसे रिप्रेजेंट करेंगे ऑल्टरनेटिंग करंट को? हाउ डू वी रिप्रेजेंट इट? सो दिस इज द सिंबल. डीसी करंट को कैसे रिप्रेजेंट करते हैं? डीसी के डीसी को हम डायरेक्टली मेंशन करते हैं 1 एम्पियर है या फिर 2 एम्पियर है, या फिर सीधा हम बैटरी लगा देते हैं सोर्स. बट हियर इन ऑल्टरनेटिंग करंट, if we want to represent the alternating source of voltage or alternating source of current, so you need to apply this symbol. This is nothing but a sinusoidal wave. Sinusoidal wave. Okay. So this picture is of sinusoidal wave, and sine function is changing from positive to negative, positive to negative. That is why we have chosen this symbol, because most of the alternating current is of sinusoidal in nature, that we are going to study in this chapter also. Okay. Now, this is the general representation of an alternating current. This from here, it is moving up, and this is nothing but the voltage time graph. Okay, clear? So V is represented as Vm sine omega t. These are the first very obvious term, that I for a alternating current, it is represented by I is a function of x and t, function of time. Okay. So when this type of quantity you are introducing, when it is a function of time and periodic function of time specifically, then that particular quantity is termed out to be alternating. Okay. So here in this graph, if you will see, this is a graph of sine function, sine theta cos theta wala function. Okay. So this sine function की terms में we are representing the voltage of this particular system. Okay. So here V is represented as Vm sine omega t. Vm sine omega. So you can see here that V is directly proportional to time. When the time will change, this whole omega t will change. And if omega t is changing, the value of sine will change. If the value of sine is changing, then the overall value of the voltage will change. Which means this particular voltage is of changing in nature. Okay. Similarly, if you want to calculate current here, it is very obvious. You can apply this Ohm's law. V is equals to IR. So V, what is the value of V we have? It is Vm sine omega t. Clear? Is equals to I into R. You can take this R here. So I is equals to Vm upon R sine omega t. Now we can say that I is equals to I naught. This Vm upon R is the value of current itself into sine omega t. ठीक है, यहाँ से आप ये भी देख सकते हो, I is also dependent on time. ठीक है. So both current and voltage, or both current or EMF of the system or the circuit is alternating in nature. ठीक है. Now Here we will understand what are the various terms here. So V is equals to Vm sine omega t. I'm writing it here only. Okay. Omega is nothing but the angular frequency of the voltage. Angular frequency means suppose this function is changing with time, and if this function is changing, there might be some term. That is why this angular frequency we have introduced here. Because angular frequency is nothing but the change of angle, theta by t. And this function depends on the value of theta. Okay? Because this Vm is somehow dependent on sine. And sine will depend on the value of theta. That is why we have written it as omega t. So complete omega t is nothing but theta. Clear? So that is why this omega is the angular frequency. After how much time this graph repeat itself, okay, that is the value given by angular frequency. Okay, number of oscillation in 1 second. Okay, clear? Now this particular value, see, this is the maximum value. Apart from that, each and every value is lesser than this, which means this is the maximum value of any particular alternating quantity. And here we have taken voltage. So this is the amplitude. This is the amplitude. Amplitude. ठीक है, what is amplitude? So amplitude को लिख सकते हो आप maximum displacement from time axis. Time axis. देखो टाइम एक्सिस ये वाली एक्सिस है, दिस इज द टाइम एक्सिस ओमेगा टी. ओमेगा टी से मैक्सिमम डिस्प्लेसमेंट में कौन सा पॉइंट है? ये पॉइंट है. दिस इज द पॉइंट ऑफ मैक्सिमम डिस्प्लेसमेंट हियर. So this particular length, which is Vm only, is termed as the amplitude of that function. Okay? And amplitude is the maximum displacement. So this particular alternating quantity, okay, V is equals to Vm sine omega t. In this quantity, Vm is the maximum value that this alternating quantity can have. Because we know that the maximum value of this function will depends on the maximum value of sine omega t. Because this is the variable here. So sine omega t will result in 1 for the maximum value. We know that the maximum value of sine omega t is 1. So that is why the maximum value of this particular alternating function is Vm. Clear? And that nothing but amplitude of the voltage. इसे amplitude भी बोलते हैं और peak value भी बोलते हैं. Similarly, in the previous case, that's why I have not mentioned what is I node in the previous slide. So here I node is what? Peak value or what? Amplitude of current. Okay. I hope this is clear to you. Is everyone make this thing very clear in your mind? Okay. Each and every data is pretty much to be clear, because if you have a doubt in this graph and in these notations, then this will create a problem for you. Okay. Otherwise, there is no problem. So if you have any kind of doubt in this, you can ask me right away right now. Okay. So I'm writing it here that for V is equals to Vm sine omega t. Omega here is the angular frequency, which is nothing but rate of change of this angular displacement. Angular displacement. ओके, मेंशन कर लेना. चलिए नेक्स्ट बात करते हैं. कंडीशन फॉर करंट टू बी ऑल्टरनेटिंग. सो कोई भी वैल्यू ऑफ करंट ऑल्टरनेटिंग कैसी होगी? तो दो कंडीशन है. फर्स्टली द एम्पलीट्यूड मस्ट बी कांस्टेंट. उसका जो एम्पलीट्यूड है वो कांस्टेंट होना चाहिए. एंड एम्पलीट्यूड से मतलब द मैक्सिमम डिस्प्लेसमेंट from the time axis of that quantity, it should be constant. इट मस्ट बी, अदरवाइज क्या होगा, आपको ऐसा ग्राफ मिलेगा, इफ द मैग्नीट्यूड इज नॉट कांस्टेंट, तो ग्राफ विल बी लाइक दिस. Is it to be categorized as a alternating current? No, the variation is not constant here. ठीक है, so that is why the amplitude must be constant. And second thing is the alternate half cycle is positive and half is negative, which means if we see this graph here, this is the first cycle, half cycle. From here to here, this is the half cycle. And for the lower one, this is also the another half. These two half combined make a full cycle. So first cycle should be positive and the second cycle should be negative. Why it is so? In the very beginning, I have told you that current which changes the direction at regular intervals with time is termed out to be alternating current. So firstly, if it is moving positive, then it has to move in the negative direction. Okay? So that is why the condition is framed in such a way that alternate half cycle is to be positive and others half cycle should be negative. I think this is clear to you. I have few examples for you. This is the sinusoidal AC wave of current. Okay. This is the triangular alternating wave current. ठीक है, ऐसा नहीं होता कि सिर्फ साइनोसोडल वेव होती है, ट्रायंगुलर पल्सेस भी होती है. ठीक है. Then we have these three examples. Now I am going to elaborate one by one which is going to be alternating and which is not. Okay. So firstly, this is to be alternating because this is a sinusoidal alternating current. First half is positive, second half is negative. This is satisfying the second condition. First condition is that the maximum value is always constant. So it is pretty much seems to be constant. So we can say that this should be satisfied the condition for alternating current. So the first graph is qualified. We can consider it as a alternating quantity, either it is current or EMF or voltage. Second thing also, if you will see these triangular pulses, firstly it is positive, second half is negative, satisfy the second condition. First condition is that this value should be constant. I hope that you are seeing it here that this value is being constant over the entire period of time. So that is why this is triangular alternating current. ठीक है, स्क्वायर ऑल्टरनेटिंग करंट भी होता है, ऐसा भी होती है पल्सेस, ऐसे भी बनती हैं. मोस्टली जो आपका पीसी होता है उसमें इसी तरह की पल्सेस चलते हैं. ठीक है ना, पॉजिटिव नेगेटिव पॉजिटिव, जीरो और वन बिट्स में. ठीक है, बिट्स एंड बाइट्स. नाउ दिस वन, टेल मी अबाउट दिस, इज इट qualifying for alternating current? No, pretty much obvious because all the cycles here, either it is repeating its value, but it is only in positive direction. Okay, so it is not qualifying the second condition. So I am writing it here, second is not qualified. So that is why it is not an alternating current because it is not changing the direction. We have the magnitude of current in the positive way only. Okay, clear? Now, this is also not qualifying. Why? Magnitude is, sorry, this amplitude is not constant. You will see the amplitude is decreasing as I move further with time. Okay. So alternating current ka amplitude is not constant here. So that is why this is not qualified as a alternating quantity. And this we can say it is in the positive direction itself. So it is the not the alternating current, but somehow if you will see it is qualifying the condition somehow. I'm not saying that fully condition to become a DC. Okay. If these cycles will reduces its value and become like this, so it is nearly we are getting a straight line. Okay. And that is nothing but a alternate, sorry, direct current, positive, constant amplitude, and not changing the direction. Okay. Here we cannot say because this is not DC because it is getting zero over a cycle. This value is not getting zero. It is just decreasing in this manner. Okay, a little bit deviation. So I hope this is clear to you. The classification is very clear to you. Okay. I'm going to elaborate it on more. But firstly, I'll have to complete this mean and RMS value of the current. So firstly, learn this definition. ठीक है, ये वाली डेफिनेशन पे बात करेंगे. व्हाट इज द मीन वैल्यू? देखो, मीन वैल्यू के बारे में आप सभी को पता है. व्हाट बी द मीन वैल्यू? एवरेज वैल्यू क्या होती है? व्हाट इज द क्वांटिटी? जस्ट टेक द सम ऑफ दैट क्वांटिटी डिवाइडेड बाय द नंबर ऑफ टाइम्स द क्वांटिटी इज रिपीटेड. ठीक है. if if in your class there are 40 plus 40 students, let's say, and you want to know the average weight of the student, what is the average weight of my class? So what you will do, you will take the weight of 40 students and then sum it up divided by the number of student itself. So you, what the value you will get? You will get a average value or mean value. Okay. In the same way, because this current is going upward and downward means this current is tends to change the direction, or this current is first half is being positive and for the second half being negative. So there is some mean value of this current to be like, because the variation, if you will see, it is a sinusoidal variation. We want something like this. Okay. That is why a mean value of this current will also exist, and we want to know that value. So firstly, what is definition says to us? Current represent the rate of flow of charge. We define mean value of the current, total charge that flow through a circuit element in a given time interval divided by the time interval. देखो, suppose 100 coulomb of charges has been flow through that particular resistor in this particular of time period. So what is the current? So current will be delta Q by delta T. And I have told you in the current electricity also that this delta Q by delta T is the average value of current. If we want to know the instantaneous value of current, it should be specific to that instant only. Clear? So that is why average means total amount of charge divided by the total time that charge has taken to be delivered. This is the value of mean value of the current. But specifically when you are in alternating current chapter, what definition you should keep in your mind is this. Because this is very simple. The first one is very simple. Now, in an alternating current manner, what is try to convey to us? What is actually mean by the mean value of current? Okay. The mean value of AC means alternating current over any half cycle, either positive or negative. तो कोई भी half cycle या तो वो positive है negative है, is that value of DC which would send same amount of charge through a circuit as it sent by the AC through same circuit in same time. Okay. देखो, suppose we are considering only this positive cycle of the alternating current. This is I and this is T. This is positive cycle. So here, if you will see from here to here, let's say time taken is T by 2, 0 to T by 2. The current is changing its value at each and every instant of time. But what if I send a value of current which is fixed, which is fixed with respect to time, it is not changing its value 0 to T by 2. And I compare this value to this value, that is the definition says to us. So mean value of this current, okay, mean value of this current, let's say lie here, is the same value of current which a DC would deliver in that same time. ठीक है. अगर एवरेज करंट, एवरेज ऑल्टरनेटिंग करंट की वैल्यू आ रही है मेरी 100 कूलाम पर सेकेंड, सो डीसी में भी मैं यही मान के चलूंगा कि वो कितनी वैल्यू होगी, 100 कूलाम पर सेकेंड. ठीक है. सो ये जो एवरेज वैल्यू है ना, ये ऐसी वैल्यू है जिसे आप सीधा सीधा डीसी से कंपेयर कर सकते हो. ठीक है. क्लियर है? ठीक है. चलो एक बार और समझते हैं इसे. देखो, मेरा वेरिएशन तो इस तरह का है. दिस वेरिएशन इज लाइक दिस. ठीक है. इन दिस वेरिएशन करंट इज चेंजिंग इट्स वैल्यू at each and every instant of time. But what do we mean by the mean value? Mean value is not change with time. So let's say the value here is I, but the mean value is coming out as I by 2. So can we say it a DC current like this? So whatever this alternating current is sending to the current element, इस करंट एलिमेंट की जितनी भी पावर है या जितना भी कुछ है, ये ऑल्टरनेटिंग करंट का जितना भी चार्ज इसने इस टी बाई टू, जीरो से टी बाई टू में डिलीवर किया है, अगर मैं टी आई बाई टू वाला डीसी करंट भी जीरो से टी बाई टू तक फ्लो करूं तो वो भी सेम अमाउंट ऑफ चार्ज ही फ्लो कराएगा. दैट इज द एक्चुअल मीनिंग ऑफ इट. ठीक है. So we are just comparing it. We are just converting it into the DC. Clear? So this is that definition. I hope it is clear to everyone. किसी को कोई डाउट है इस डेफिनेशन में? हेमचंद्र, विशन, JNV रोइंग, योगेश्वरी, मधुकर रेड्डी. Please unmute yourself and then say if you have any kind of doubt or if it is clear to you also. I'm waiting for your response. Huh? And do not make me to take my each and every individual name and then ask. Okay. Okay, very good, Yogeshwari. Only Yogeshwari has understood it. JNV Rohing, Bishan. What about you, Hemchand and Madhukar? What about you guys? So, how to calculate that mean value? And send me your responses, Madhukar and Hemchand. If any doubt, you can ask. I is equals to dq by dt. This is the instantaneous value of current. What we can do here, dq is equals to I dt, and then if you want to calculate the total amount of charge, it would be integration of it. So q is nothing but the integration of 0 to t. Just a second. So here this is dq. dq is the amount of charge that is being flown for dt time, small dt. ठीक है. So dt dq, total dq निकालने के लिए we just integrate it over the period of time 0 to t, and what we get it here is I mean is equals to 0 to t, capital T I dt. We put the value of charge because according to the definition, if you will see, the total charge that flows through a circuit element in a given interval of time, okay, divided by the time interval. So total charge being flown is capital Q, which is written as 0 to t I dt divided by total time taken, which is 0 to t dt. Okay? 0 to t dt will give you capital T only. So it is total time taken to flow this amount of charge. This is the mean value of current. Clear hai? Now, for a complete cycle, I mean is 0 for alternating current. For the complete cycle, for this complete cycle, this is one cycle. After that, the another cycle is being repeated. ठीक है. इस साइकिल के लिए मीन वैल्यू इसकी क्या हो, 0. वाई 0. देखो यहाँ पे पॉजिटिव है, उतना ही अमाउंट नेगेटिव चला गया, सेम अमाउंट नेगेटिव हो गया. ठीक है. If this amount is positive, let's say 10 unit, same amount is negative in 10 unit. So what is the average of it? 10 minus 10 will be 0. So that is why the mean value of the current over an entire cycle will be 0 always. So we always calculate the mean value of current for a half cycle. Okay. So now we will do that for half cycle. What is the value of mean value of current? Here I have mentioned some references so that you do not worry about how I have taken it. Okay. So this sign, this greater than less than, this sign represents average value of sin theta. Okay. So average value of sin theta, sin 2 theta is 0 for a complete cycle, for a complete cycle. And what is the cycle of sin theta? It is 0 to 2 pi. Okay. So 2 pi is the cycle length of sin theta. What I mean by cycle here, when these quantities starts repeating its value. तो देखो साइन का ग्राफ कैसे मूव करता है, ऐसे एंड देन फिर ऐसे स्टार्ट कर दिया, तो यहां से रिपीट करना शुरू किया, यहां से यहां तक, फ्रॉम हियर टू हियर, व्हाट इज द वैल्यू ऑफ एंगल। ठीक है, देखो, वी नो दैट साइन मैक्सिमम वुड बी एट 90 डिग्री, so this value would be 90 degree. Again here we have 90 degree, which means this total will become 180, sorry, 0 to this will become 180 degree, and again 180 degree, because sine 0 is 0, sine 180 is also 0, then again it has started its value in the negative manner. Okay, this is for 270. If you calculate the value of sine 270, what it should be, it will changes to cos 90, and cos 90 is, sorry, 270, and it will changes the value magnitude, so it is coming out as minus 1, because 270 lies in the third quadrant, and this quadrant sine theta will be negative. Okay, so that is why sine 270 you are having a negative minus 1. Okay, negative 1, and then again for 360 it is 0. So for 360 degree is the cycle length of the sine theta. 360 degree means 2 pi radian. Okay, so we will only talking about the radian in terms here. So 2 pi radian is the full cycle length of sine theta. Clear है? So average value of sine theta, sine 2 theta is 0, cos theta, cos 2 theta is 0, and sine theta, cos theta multiplied is 0. Sine square theta and cos square theta is half for an entire cycle. Okay? Now, let's just get started with what is the mean value for a half cycle of alternating current. So we know that I is nothing but I is equals to, from this equation we can say I is equals to Im sine omega. Okay, this is starting from 0. So this is the equation of alternating current. We have seen in the previous slides. So we want to know the value for half cycle. We know that I average or I mean is nothing but, in the previous slide I have mentioned, it is I dt, from where to where we want to calculate it. So we want to calculate it for t by t, divided by 0 to t, 0 to t by 2 into dt, because time period has changes 0 to t by 2. For full cycle, it is 0. So no value of point of calculation. Now, put the value here. It is coming out to be Im sine omega t dt, divided by 0 to t by 2, divided by t by 2. So we can say it as 2 by t integration 0 to t by 2 Im sine omega t. Im is a constant, a maximum value of the current, sine omega t. So what is the integration of sine omega or sine theta? Integration of sine theta is minus cos omega, minus cos theta. So here it will be minus cos omega t. But since this is also reacting as a function here, omega t, so this omega will divide, okay, in the values. So sine omega t का, always remember sine ax का इंटीग्रेशन क्या होता है, 1/a cos ax. ठीक है, तो जो भी क्वांटिटी यहाँ पे मल्टीप्लाई है विद दिस वेरिएबल, it should be divided by the final resultant value. Clear? So it is 2 by t, from here 2 by t integration Im को also we will take out. Integration of sin omega t will become cos omega t minus cos omega t divided by omega. ठीक है, 0 to t by 2. Now put the value here, 2 Im upon capital T into omega, और omega capital T. ठीक है, put the value minus cos omega capital T plus cos 0. ठीक है, cos 0 is nothing but 1, एंड ये प्लस कैसे हुआ, आई थिंक आई नोट, लिमिट जब भी हम इंटीग्रेशन में पुट करते हैं, इट शुड बी b minus a, upper limit minus lower limit. So when we are putting the lower limit here, this quantity already contain minus. ठीक है, so is it like minus b, is it like, let's say here is x minus x, So it will become minus b, and then this minus will plus because this is already minus here. Okay. So this, that is why it is being plus. So cos 0 is 1 here, cos omega t. Now what we will do, we will use the formula that omega is nothing but 2 pi by capital T. Okay. You should remember this. Okay. So we put the value here. It is become 2 Im upon T omega into minus cos omega t की प्लेस पे we will put 2 pi by 2 pi by capital T into T. T and T will cancel out, plus 1. Sorry, the value that we have to put in the calculation is T by 2. Okay. So it is T by 2. Yeah. So here limit is T by 2. No? That is why. So it is 2 Im divided by T omega into, this will become, देखो, this will become what? 2 and 2 will also cancel out. So it is become cos pi minus cos pi. Minus cos pi. Cos pi की वैल्यू क्या होती है? -1. And already minus is there. So it is become +1. This whole will become +1, and this +1 is +2. So finally we are getting that I average is nothing but 2 Im upon, sorry, 4 Im अपॉन ओमेगा कैपिटल टी, और ओमेगा कैपिटल टी की वैल्यू यहां से हम रख सकते हैं क्या? 2 पाई. So when you put it here, let me change the color here. So I average will become 2 Im upon pi. Okay. So this is the value of the average value of alternating current for a half cycle. Okay. So always remember this formula. Okay. One of the trick that you can use to remember this formula is that I average is nothing but I maximum. Just a second. I average is nothing but I maximum, whatever the maximum value, divided by half of the cycle length. अब यहाँ से यहाँ तक कितना साइकिल लेंथ है? T/2. T/2 पुट करोगे तो वैल्यू इज गेटिंग पाई. मैंने पहले भी बताया था आपको पिछली स्लाइड में. ये वैल्यू कितनी होती है? पाई. सो पाई/2 विच मीन्स हाफ ऑफ साइकिल लेंथ. हाफ ऑफ साइकिल. ठीक है. Im अपॉन पाई/2. ठीक है. आई होप दैट एवरीवन is clear with this concept of how to calculate the mean value of half cycle. किसी को कोई डाउट है? Anyone, any kind of doubt? No, yes and no. ठीक है. So we will do the RMS value of the current. ठीक है. What is actually the RMS value? ठीक है. RMS value से क्या मतलब है? चलो बात करते हैं अभी. RMS value is defined as defined as the root mean square value of current. Okay. Clear? Which means whatever the value of current you have, you firstly square that value, then you have to take the mean of square values. ठीक है. आपके पास जो भी वैल्यू है उसका क्या करेंगे, सबसे पहले मीन लेंगे, मीन ऑफ स्क्वायर एंड देन टेक द स्क्वायर रूट ऑफ। क्लियर, ये इसका मतलब है। चलो, इसका फॉर्मूला कैसा है, आई इज इक्वल्स टू आई आर एम एस इज गिवन बाई, आई आर एम एस इज गिवन बाई स्क्वायर रूट ऑफ, देखो अगेन स्क्वायर रूट ऑफ जीरो से टी बाई, जीरो से टी आई स्क्वायर, आई स्क्वायर डी टी डिवाइडेड बाई जीरो से टी टोटल टाइम। ठीक है, दिस स्क्वायर इज फॉर टोटल। क्लियर, नाउ अगेन we want to calculate the value for full cycle, just calculate it. So we know the equation of current which is I is equals to Im sin omega t। देखो sin omega t मैं क्यों लगा रहा हूँ, क्योंकि this value of current is behaving as it is a sine wave। ठीक है, positive negative and the mathematics that is follow is of sine function, so that is why I'm writing this equation in the form of sin omega t। क्लियर है, चलिए। So again what we will do, this is equation number 1, now change the color here, put it into the equation IRMS is equals to square root of 0 से t I square dt, which means Im square sin square omega t dt divided by 0 से t dt equals to, now just the mathematics here, take Im square outside of the integration because it is a constant quantity, 0 to t, Im square is what, sin square omega t का integration, we don't know, so we have to make it like this so that we can integrate it। ठीक है, so I'm doing it here and then I'll put the value directly here। So integration of sin square omega t, this is the problem here। We know that cos 2 theta is equals to 1 minus sin square theta। ठीक है, this is the formula, 1 minus 2 sin square theta, sorry, 1 minus 2 sin square theta। So can we say that cos 2 omega t is equals to 1 minus 2 sin square omega t? Yes, do we can say that. So if you get the value of sin square in terms of only cos function, it would be better to integrate it. 2 sin square omega t equals to 1 minus cos 2 omega t. Then sin square omega t will become 1 minus cos 2 omega t divided by 2. Now it is very easy to solve this expression rather than this. So you put the expression here. Now I am solving it here only. It will become 1 minus cos 2 omega t divided by 2 dt divided by t। ठीक है, 0 to t dt is nothing but t only, equals to, देखो मैं स्क्वायर रूट को ना पावर हाफ करके लिख दूंगा बिकॉज इट इज ग्रैबिंग अ मोर स्पेस हियर। सो या, सो आई एम स्क्वायर इंटीग्रेशन 0 to t 1 minus cos 2 omega divided by 2 dt, and this is t, im square by t इंटीग्रेशन 1/2। अब इंटीग्रेशन को डिस्ट्रीब्यूट कर देंगे तो इट इज 0 to t 1/2 dt, because it will become 1/2 minus cos 2 omega t by 2 minus cos 2 omega t by 2 into dt। Clear? Integration 0 to t. It is become Im square by t. 0 to t will become integration of 1 by 2 dt is nothing but 1 by 2 into t. This is nothing but t by 2 minus again 1 by 2 we can take common. Integration of cos 2 omega t will become sin omega t. Okay. Cos integration of cos theta is nothing but sin theta. But I have told you sin ax ka integration will minus cos x by a. So here cos 2 omega t ka integration will become sin 2 omega t divided by 2 omega. Okay. So it is sin 2 omega t divided by omega 2 omega 0 to t. Again, we will play with this formula, which is I'm writing it here, which is omega t, capital T is nothing but 2 pi. Okay, so directly I'm writing it here. Either you can put the value of t in terms of omega and 2 pi, or you will put the value of time in terms of omega in terms of t. It's up to you. So previous case mein we have put the value of omega in terms of t. In this case, we will put the value of t in terms of omega. Chalo. Im square by capital T into t by 2 माइनस देखो यहाँ पे ये t by 2 बनना है तो वी हैव टू पुट द वैल्यू ऑफ ओमेगा इटसेल्फ सो दैट इट विल आल्सो बिकम इन t. ठीक है तो 1 by 2 this will become 1 by 2 1 by 4 omega 2 omega I have taken common so it will become 4 omega sin 2 omega capital T sin 2 omega capital T minus sin 0 sin 0 is 0 sin 2 ओमेगा टी. अब इसी की बात करते हैं. टी की वैल्यू क्या आएगी यहाँ से 2 पाई बाई या ओमेगा की वैल्यू बिकॉज वी वांट द एक्सप्रेशन इन टर्म्स ऑफ टी. सो ओमेगा की वैल्यू क्या आएगी 2 पाई बाई कैपिटल टी फ्रॉम द प्रीवियस स्लाइड ऑल्सो. सो इट इज आई एम स्क्वायर बाई कैपिटल टी टी बाई 2 माइनस 1/4 ओमेगा इंटू साइन 2 ओमेगा टी. टी की वैल्यू क्या हो जाएगी 2 पाई बाई टी 2 ओमेगा एंड ओमेगा की वैल्यू ओमेगा की तो वैल्यू रखनी है विच इज 2 पाई बाई कैपिटल टी एंड यहाँ पे भी कैपिटल टी. कैपिटल टी एंड कैपिटल टी विल कैंसिल आउट सो इट विल बिकम साइन 4 पाई साइन 4 पाई एंड साइन 4 पाई साइन एन पाई इज ऑलवेज क्या साइन एन पाई is always 0. This expression will become 0. If this expression will become 0, so only t by 2 will be remaining. So IRMS की value is, and this t and t will cancel out. So it is becoming as I, and one thing we are missing here is the square root, power half. ठीक है ना? So I am mentioning it in the last here. It is Im square by 2 by square root. ठीक है? Which basically Im upon root. ठीक है? So this is the value of RMS, value of current. ठीक है? This is the RMS value of current, which is nothing but 0.707 IM. मैक्सिमम वैल्यू का 70%. क्लियर है? क्लियर? एनी काइंड ऑफ डाउट? नो, नथिंग एल्स. चलो, so this is over now. I hope that you have enjoyed the today's session. I'm launching a poll. Just do answer in that poll for your attendance. Each and every question of the poll, and then you can leave the class. The lecture is being over. Thank you so much for being attentive and being responsive. If you have any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you, guys. Thank you so much.